Welcome to the guided reading and notes for the motion. Today we're going to be focusing on distinguishing between speed, velocity, and acceleration. We'll do that by defining speed and learning how to calculate speed. Remember our essential question for this section. How does an object's speed and acceleration affect its motion? Simply said, speed and acceleration directly affect an object's motion. So let's begin by reading. Now whenever I start to read, I take a look at the graphics on the side. Here, this will allow me to get an idea of what I'm going to be reading about. It gives me vocab words for speed and constant speed. So that means that this will be about, or my reading will be about speed and constant speed. So let's begin. Nothing in the universe stays still. A book on a table appears to be sitting still, but Earth is moving in its orbit around the sun at a speed of 66,000 miles per hour. You and the book move with the Earth. Speed is an important concept in physics, and saying that something is fast is not descriptive enough to accurately convey its speed. A race car may be fast compared with other cars, but it is slow compared with a jet airplane. In this section, you will learn a precise definition of speed. That's a good sentence to allow me to know what I'm going to be reading about. So let's look. An example of speed. Consider a bike moving along the road. The diagram below shows the positions of two bicycles at different times. To understand the concept of speed, think about the following two questions. How many meters does the bicycle move in each second? Does the bicycle move the same number of meters every second? So I'm going to look at the diagrams. It shows me every meter, 1, 2, 3, the bike moves 1. For every second, the bike moves 1 meter. Let's look at the second one. For every second, the bike moves 3 meters. So that tells me that the speeds are different. This bicycle is moving at a speed of 1 meter per second. This bicycle is moving at a speed of 3 meters per second. The precise meaning of speed. The speed of a bicycle is the distance it travels divided by the time it takes. So that must be the definition of speed. At 1 meter per second, a bicycle travels 1 meters per second. At 3 meters per second, it travels 3 meters each second. Both bicycles in the diagram are moving at a constant speed. Constant speed means it moves the same distance as traveled every second. Very good. Let's continue. Calculating speed. That is my second goal of the day, is learn how to calculate speed. Speed is the measure of the distance traveled in a given amount of time. Therefore, to calculate the speed of an object, you need to know two things: distance and time. Speed is calculated by dividing the distance traveled by the time taken. For example, if you drive 150 kilometers in 1.5 hours, then the average speed of the car is 150 kilometers divided by 1.5 hours, which is equal to 100 kilometers per hour. So I'm thinking, what does that per mean? And in my mind, I'm thinking per means divide. So let's read this. What does per mean? The word per means for every or for each. The speed of 100 kilometers per hour is short for saying 100 kilometers for each hour. You can also think of per as meaning divided. So I'm going to make an inference here, and I'm going to think about the equation for speed. I'm thinking the equation for speed is distance, because you need to know distance, divided by time. Units for speed. Since speed is a ratio, once again, that means divide, of distance over time, the units for speed are a ratio of distance units over time units. So that tells me that the units will change depending on what I'm using to measure the distance and the time. In the metric system, the one that we will use, distance is measured in centimeters, meters, or kilometers. If distance is in kilometers and time in hours, then speed is expressed in kilometers per hour. I'm going to look down here, common units for speed. This will be a good table for me to look at so that I can understand what we will usually be using for speed. We'll usually be using meters per second, and it also gives me the abbreviation, so if I ever need a reference to go back and look. Let's take a second and get out our guided notes so that we can fill out a few things. I'm going to fill out the definition for speed. The definition for speed is the ratio of distance over time. I want you to pause and think of an example that you could type into your guided notes of speed. Constant speed means, now I forgot this, so I'm going to have to go back to my reading, when the same distance is traveled every second. So I'm going to go back, same distance for every second. All right. Now, let's fill out some of our number notes. The definition of speed: a measure of distance traveled in a given amount of time. Now you fill out the two things you need to calculate for speed and the units of speed.